chapter number 10, straight lines. Now this chapter is from coordinate geometry. Some part of coordinate geometry you already did in 10th standard. Cartesian plane R2, that is Cartesian plane, coordinate plane, we know it. We have two coordinate axes, x and y axis here. Let me just remind you, you already did from 9th standard. So these are the two coordinate axes. We have here x axis, this is y axis, this is horizontal line, this is vertical line. These two are perpendicular to each other. This is, we know, origin here. In the first quadrant, we know both the coordinates are positive. Here negative, positive, here negative, negative, and here we know positive, negative. As far as coordinate concern, we know this, right? And if you take any point from this, say P, then it has two coordinates, one from this and one from this. Usually we call x comma y. So in R2, that's called simply plane or Cartesian plane. In R2, in a plane, every point has two coordinates. We know it, two coordinates. We usually call them as x and y coordinates. So if I pick up a point from here, then we write two coordinates like x comma y. If I take one point P, if we call x comma y, suppose I take another point, again it has two coordinates. So in that case, I'll call x1 y1 and x2 y2. If I take one more point here R, then I can take x3 y3. This much we know from 9th and 10th standard. This is about coordinate geometry. Now, just let me recap what you did in 10th standard. The one was distance formula, if you just recall, that is from 10th standard. So if you are given 2 points here, P and Q, in Cartesian plane, one is P, the other one is Q, then you can get the distance between these two. That we know. Suppose coordinates x1 y1 here and x2 y2. x2 y2, this be two coordinates. So how do we get the distance between these two? If you just recall, that's called the distance formula. Root of this minus this the whole square plus this minus this the whole square. x1 minus x2 the whole square plus y1 minus y2 the whole square. This is known as distance formula. That gives us what? Distance between 2 points in R2. R2 means what? Cartesian plane. In this chapter we talk about Cartesian plane only. Okay, so this one we know. Even that's called as sometimes division or segment formula. Division formula or segment formula. What is the division formula? You are given a line segment here. Let's take A, B. This is a given line segment. Coordinates be x1 y1, here x2 y2. You have a point, maybe inside or outside the line. Say suppose there is a point P, right? It can be anywhere here or it may be outside also. It can be anywhere on the line AB. In fact, point P may be here, but it is on this line. So here, suppose we say that P divides, P is called point of division. P divides line segment AB in, say, m:2n ratio. So this AP upon PB, this upon this, which ratio? AP upon PB. That's given to you m/n ratio. This is 2 units and this is 3 units, then 2/3 units, that way. So therefore we have this ratio. Then if you have the ratio, you can write the coordinates of P. So coordinates of P we can write. Coordinates of P equals to, this is known as division formula, you know it here. I'll write it here. If you just recall, what is that? This is m unit, this is n unit. So here it is given by this mx2 plus nx1, not difficult to remember, upon m plus n. Here also m plus n, just you are going to change the coordinates, my2 plus ny1, my2 ny1. This is known as division formula. What it gives? It gives the coordinates of the point P that divides the line segment AB in m:n ratio. What is this division formula or section formula? It gives the coordinates of the point P which divides the line segment AB in which ratio? m:n ratio. Okay, now as a particular case, you can take point P somewhere exactly in the middle of the line segment AB. This is exactly in the middle of the line segment AB. So here this becomes the midpoint. This is nothing but the midpoint. It is exactly in the middle of line segment AB. So this one and this one both are same. So as per our symbol, if this is m and this is n, then here m equals to n. Ratio would be same. If this is 2 unit, then this is also 2 unit. So m by n will be 1 here. So if you use m equals to n here, then the coordinates of the midpoint here, it would be just m equals to n. If I place here and if I cancel it, it will be just x1 plus x2 by 2, comma y1 plus y2 by 2. This one also you know, coordinates of the midpoint of the line segment. It's just average here. What are the coordinates here? x1, y1. What are the coordinates here? x2, y2. So x1 plus x2 by 2, y1 plus y2 by 2. Right. This is the midpoint. This is nothing but the midpoint, coordinates of the midpoint. Okay, so one is this, and one more thing which also you did in 10th standard, that is area of a triangle. If you are given this triangle with the coordinates, one basic formula you know, half base into height, that we know. But here everything we are doing in terms of the coordinates. One you know, area of the triangle with half base into height. We don't want to use this here. This we know from the geometry. We want to use this coordinates of the vertices of this triangle. So here area of this triangle ABC, that you know. So area equals to half. Inside the modulus you have some expression here. What's that expression? It's even not difficult to remember. x1 y2 minus, just interchange these two indices, x2 y1 plus, now here you had started with x1, so now you start with x2, next index y3, and then interchange this two, x3 y2, 1 2. Now we'll take the next one, x3 in circular y1 minus, interchange these two, that is now x1 y3 inside the modulus. Everything is in terms of this coordinates. Place the value. In case if it is negative, make it positive and put half in front of this. This is the area of a triangle, you know it. I repeat how I wrote this: x1 y2 minus here x2 y1, then here 1, now we start with 2, x2 y3 minus here x3 y2, interchange these two indices. You had used x2, now x3, in circular it is y1. So here what we have? We have x3 y1 minus, here interchange these two, that is nothing but what? x1 y3. Right? This is one way. If you know some another way, the final answer will be same, but this is basic formula. Okay, this much is up to 10th standard, you did it and you know it. Now we go to the beginning of this chapter, which is about lines, and the first concept is about slope of a line. Slope of a line. Line, we mean always a straight line. We are defining what's the slope of a line. Okay, so what we'll do, we consider a line making certain inclination with the x-axis. X-axis means ground. Here, let me show it. For example, this is x-axis here. I'll just show two coordinate axes. This is y-axis. X-axis is always, parallel to ground. This is y-axis. Now I'll draw a line which makes certain angle with the x-axis. For example, this is a line, right? So this is called inclination of the line with the ground. This one, right? If line is like this towards the x-axis, then inclination would decrease. And if line is like this, if it is like this, for example, like this, then inclination would increase. Inclination means what? Angle of the line with the ground. So here, I'll call this as theta. So what is this theta? This line, let me call this as line L. So here line makes an angle theta, makes an angle theta with, you see the way I've shown the angle. This is origin. If you move towards right, this is sometimes called positive direction. If I move towards left, this is called negative direction. So I'll write with, this is with which direction I have considered positive direction. I have not considered this angle. This is with negative direction. With positive direction of x-axis. Direction of x-axis. So this is very important. What I've written? Theta, that's called inclination here. What's this theta? That is nothing but, theta is nothing but inclination. Measure of inclination. How much is line inclined with the ground? This is nothing. So here obviously that's theta varies from here to here. So it is from 0 to 180 degree, which is pi. This is range on theta. But what is important here, this angle is with the positive direction of x-axis. We have not taken this angle here with negative direction. Once we have this, then the slope, that is nothing but the measure of inclination of this line with the ground. Right? It is indirectly nothing but the slope represent what? Precisely rising or falling off the line. It is nothing but what? Rising or falling off the line. If the line is like this, for example, you see like this, exactly like this, then there is no rising or falling of the line. So slope will be 0. But as it moves towards like this, here you see the inclination is increases. That means slope is increasing, the rising is increasing, right? Or you can say that it is nothing but the measure of the steepness, right? Big slope, big steepness, like this. Now, if the line is like this, you see the slope is very high, rising is very high. So slope is indirectly measure of rising or falling of the line. It is also called sometimes gradient of the line. It is also called gradient of the line. It is also called gradient of the line, and it is defined as the tangent value of the angle theta. Tangent value means tan theta. So this is the definition. What's the definition of the slope? Tan theta. Tangent value of angle theta. Tangent value. Tangent value means what? Tan theta. Tangent value. It can be proved very easily why tan theta is taken. We are not getting into that, but it is tan theta. What is theta? I emphasize again on that. That's the angle made by the line with the positive direction of the x-axis. We have not taken these as a theta. So of course this theta increases, you can see that the rising would increase. So slope will be big. Big slope, big rising, big or big falling, whichever you say. But one thing is obvious, if this is acute angle, then the slope will be positive. So let me show that. Okay, so now you know slope of any line is this. Slope equals to tan theta, tangent value of angle theta. What is theta? Angle made by the line with the positive direction of x-axis. This is very important. With the positive direction of the x-axis. And now look at these two figures. If I show line like this, then this is theta with the positive direction of the x-axis. You can see that this is acute angle from the diagram. So here slope, normally slope is denoted by small m. Let me write here. So here m equals to tan theta is positive. Slope is positive. Because in the first quadrant tan is always positive. Now see here. If I take the line like this is a line. Now this is a line, this is x-axis. Which angle you are going to take? This one with the positive direction. Now this is theta. It is obtuse angle. So obviously here it is from pi by 2 to pi, because range of the theta is always from 0 to pi. So pi by 2 to pi, more than 90 degree, it will be in the second quadrant. So tan theta is negative. So what I'm trying to tell you that here slope is positive. Here I'm saying that slope is positive. Here I'm saying that the slope is negative. Slope can be positive or negative. Or if the line is like this is x-axis, this is y-axis. Suppose line is like this is line. Parallel to x-axis. So what's the angle with the x-axis? Obviously theta equals to 0. Or you can say that it has no rising. Or you can say that it has no inclination with the x-axis. So what is the slope here? Slope m equals to, what is the angle? 0. What is tan 0? 0. So slope is 0. So from this you can say that the slope m is a number. Slope small m is a number. Can be positive or negative or 0. What it represents? Steepness of the line. Big the slope, big the steepness. Remember, or it represents the rising with the line. You see like this here. If this is x-axis, if the line is like this, slope will be very small. Slope increases. Slope increases. Slope becomes very large here, because inclination becomes very large here. Fine. So in general, slope is a number, can be positive, can be negative or 0. Slope is a number associated with the line. It can be 0, positive or negative. For which line it is 0? If it is horizontal line. You know this is called the horizontal line. What slope represent? Inclination. Here there is no inclination with the ground, you see. So slope is 0 here. So for horizontal line, slope is 0. Slope m is 0 here, as I explained here. But if I take a vertical line like this is the line which is perpendicular to x-axis. So what is angle here? 90 degree. So for vertical line that is parallel to y-axis or y-axis itself. So slope m equals to, what is measure of angle? 90 degree, which will be, tan 90 undefined. Here this is undefined. Tan 90 is undefined. So what's the slope of vertical line? Undefined, very large. You see, rising is very large. Here rising is not, there is no rising, so slope is 0 for this one. For horizontal line, slope is 0. For horizontal line, slope is 0. But what about for vertical line? Slope is undefined. It's very large. Fine. So what we have concluded from this, slope of A line is nothing but tan theta. That's the first thing we have concluded here. Slope of any line is tan theta, number 1. What is theta? That is the angle with the positive direction of the x-axis. Slope can be positive, negative, or 0. Slope of any horizontal line, or you can say x-axis, is always 0. And slope of vertical line or y-axis is always undefined. Fine, you have tan theta formula. You can find the angle with the positive direction of the x-axis. I repeat, 3 things we did so far. What is the slope? That is nothing but the rising or falling of a line. How will define? By tan theta. What is theta? That is the angle of the line with the positive direction of the x-axis. As I shown, these or this. Slope can be positive, negative, or 0. Where the slope becomes 0? If the line is horizontal or x-axis itself. Where the slope is undefined? If the line is y-axis or any vertical line that is parallel to y-axis. There the slope will be tan 90, which will be undefined. Why 90 I have chosen here? Because for vertical line, angle with the x-axis is always 90 degree, and which is undefined. Undefined means very large. Okay, now we get the slope of a line, gradient of a line, or inclination of a line with the ground when we are given 2 points. So you have a line where 2 points you are given with the coordinates x1, y1, the other one will be x2, y2. There's 2 points on the line you are given. Angle of this line with the ground you are not given. Then the slope is tan theta, we know. So here slope of line AB, when 2 points were given, which is equals to small m, that is given by, can form the right angle triangle, and then it can be derived. It is given by y2 minus y1 upon x2 minus x1. This is a formula to get the slope. It is just tan theta if you form a right angle triangle here. This is simply tan theta. If I form a right angle triangle here, tan theta will be this. We are not getting into that proof, but this is another way of defining the slope. What is the slope? y2 minus y1 upon x2 minus x1. Difference of y coordinates upon difference of x coordinates. This is the formula to get the slope. y2 minus y1 upon x2 minus x1. If we are given 2 different points on the line, then we can get the slope by this formula. Like this, for example, here we are given 2 points. Let's take 1, 2 here. The other one is 3, 4. So what's the slope of this line? So here slope equals to small m equals to y2 minus y1, that is 4 minus 2 upon 3 minus 1. I repeat what I did. y2 minus y1 upon x2 minus x1. So 4 minus 2, 2, and this is again 2. So this is 1. So slope of the line equals to 1 here. It's a number, as I told you. It can be positive, negative, or 0. So slope of this line is 1 here. Slope is a number. Here it is 1. It is the measure of inclination or rising or falling of the line with the ground. Right? If it is ground, then how much inclination is there of the line with the ground, that represented by this. Okay. If I take such 2 points, let's take PB 1, 2 and QB 3, 2. Suppose I take these 2 points. Then what's the slope of PQ? Line PQ. y2 minus y1 upon x2 minus x1. 3 minus 1, which is 2. So what will get? 0. What's the meaning of this? Slope is 0 means it must be parallel to which axis? It must be parallel to, if this is x-axis, the line must be parallel to x-axis. Right? It has no inclination, no angle with the ground. It has to be 0. So this line must be, this is just for your information, you can say PQ must be horizontal line. Horizontal line. Horizontal line means what? Parallel to x-axis. It should not have any inclination with the x-axis, should not have any angle with the x-axis. So here slope is 0. y2 minus y1 upon x2 minus x1. Now look at one more example. I'll take such 2 points. Let us take A as, for example, minus 1 comma 3 and Q as, let's take minus 1 comma 5. Okay, I'll call this as B. So what's slope of AB here? Slope of line AB, let's write it y2 minus y1. 5 minus 3 upon x2 minus x1, minus 1 plus 1. So you can see that you are getting 2 by 0, which is undefined. Right? It means it has very big slope. That means it has high inclination. It means this line AB must be parallel to which axis? Parallel to y-axis. It means it must be vertical line. It must be vertical line. If this is x-axis, this is y-axis, then line must be like this. This is a line. This has to be 90 degree in this case. Points must be anywhere on this line. So here slope is very large. We call it undefined or infinity. Slope is very large here, undefined or infinity. Fine. So it has to be parallel to y-axis, or you can call it vertical line. The earlier one was, horizontal line. Okay. That's one thing. Now, you know two ways to get the slope of the line. One is by tan theta and the other one is y2 minus y1 upon x2 minus x1. The next one we want to write condition for two lines to be parallel. Condition for first parallel lines. You know from the geometry what you mean by parallel lines. The second one, that's perpendicular lines. Perpendicular lines. Parallel means what? Non-intersecting lines. Two lines which never meet, such lines are called parallel lines. Non-intersecting lines are known as parallel lines. So here we have such two lines like this. Suppose we have two non-intersecting lines here. Let's take line L1, and every line has a slope. Now you know, we call here M1. Another line, let's call this as M2. Two lines are parallel. So it can be derived that if two lines are parallel, then the slopes are equal here. So M1 equals to M2. If and only if, double implies you can write the lines are parallel. Lines are parallel. This is a very important condition. In general, it's difficult to check whether lines are intersecting or not. But with this condition, you can check very easily. What this condition says, lines are parallel if and only if their slopes are equal. Right? It can be proved using the concept of, transversal of two parallel lines. If this is x-axis, you take this as one angle, the other one as this angle. These are the two angles. These are the two parallel lines. So this become, pair of corresponding angles. So tan theta 1 equals to tan theta 2 and equals to, will get M1 equals to M2. But anyway, that proof is not important. What is important one is this condition. What this condition says, lines are parallel if and only if slopes are equal. Slopes are equal. For two lines slopes are equal, that means line must be parallel. And vice versa. If lines are parallel, then the slopes must be equal. That's one condition for parallel line. If you have perpendicular lines, there is one. Now if you have perpendicular lines means what? They intersect at right angle. We know. So we have such two lines. They meet at right angle. So one line L1 it has a slope, call M1. There's another line L2, it has a slope, call that as M2. They meet at 90 degree here. Then again, it can be derived that the lines are perpendicular. Without proof we are writing lines are perpendicular. Lines are perpendicular if and only if product of the slopes equals to -1. Right? We have not derived this, I've stated directly. What this formula says, product of the slopes equals to -1. This condition says that the product of slopes equals to -1, then two lines must be perpendicular to each other. That means if the slope of this line is, for example, 2, then the slope of this one has to be -1 upon 2. If this is, for example, M1, then this has to be M2, if two lines are perpendicular. Here slopes will be equal. Fine. So if here, if I have lines like this, if the slope of this one is 2, then the slope of this one has to be 2 because they are parallel. Fine. If I have lines like this making 90 degree angle, if slope of this one is 1 by 2, then this one has to be -2. So here which condition? M1 into M2 equals to -1. Product of the slopes should be -1 if two lines are perpendicular. And there, what's the product? What about there? Slopes are equal. Here product equals to -1, here slopes are equal. Okay, we use it effectively in exercises. Now next one, we want to write the angle between two lines. The next point, that is angle between two lines. We want to write the formula to get the angle between two lines. Now you see here, if I take lines like this, I mean parallel lines like this, parallel lines. So here there is no angle between these two, obviously. If I call the alpha, there is no angle between these two, so alpha is 0 in this case. Angle between two lines. Fine. Now if I take intersecting lines, for example like this, making, obviously here let's take 90 degree angle, L1 line, L2 line, they intersect at 90 degree like this. So here angle between two lines is 90 degree. Between two lines here, two lines is alpha equals to, let's take 90 degree here. Alpha, which is 90 degree here. Now the case is, if two lines are not parallel or not perpendicular, I mean they intersect at some angle like this, acute angle in general, I would say, like this. Such two lines we are talking, L1, L2. Not this case, not this case, neither parallel, no perpendicular. Let's take this as alpha, for example. Okay, every line has a slope. I'll call this as M1. You know, now slope can be determined for every given line. So this is M1, this is M2. What is alpha? Alpha is the measure of angle between these two. Measure of angle between these two lines. Angle between two lines. Now you can see this is also measure of angle between two lines, but that's an obtuse angle. Usually when we say that the measure of angle between two lines, it's taken as an acute angle. If this is, for example, 60 degree, then this has to be 120 degree because this total is 180 degree. 120 degree is not considered as angle between two lines. 60 degree is considered as always angle between two lines. So here alpha always vary from where to where? 0 to pi by 2. You know 90 degree is same as pi by 2 here. So if it alpha equals to pi by 2, then that is this case. If alpha is 0, then it is this case. So here it's an acute case. So in this case, this alpha is given by this formula. So alpha can be computed using this formula. Can be computed using this formula. This is the formula. I'll just state it. Proof is also there in the textbook if you're interested. Tan alpha equals to, inside the modulus, m1 minus m2 upon 1 plus m1 into it. It is the formula. Right? Where alpha always varies from where to where? 0 to pi by 2. If it is 0, then it is this case. If it is pi by 2, then it is this case. So it is an acute case. That's why, in fact, we have placed the modulus here. Right? So this is the formula to get the measure of angle between two lines. What's the formula? Tan alpha equals to, inside the modulus, m1 minus m2 upon 1 plus m1 into m2. What is m1 and m2? These are the slopes of the given two lines. Right? So we use this formula. Right now I'm not discussing any example, but we have plenty of examples in the exercises. So this is theory connected to the first exercise, which we will discuss in the next session. Right? But it's very fundamental theory.